might recall we worked with waves in one dimension in grade 11 physics. Typically what would happen is we would oscillate a rope, and if things were right, if we could just get the frequency right, we could generate these standing waves. So I'm going to change the frequency a bit and see if I can get a standing wave, where interference would cause a crest from the reflected wave to line up with a trough from the incident wave, and I would get things like nodes, which are places which wouldn't move. And I'm not being very successful. Maybe I've got a node. No, I don't really have a node. I've got a node over here. We're going to change that up so that we can look at light and compare its properties to the properties of a wave. In particular, we're interested in interference patterns we might see that would indicate that light is a wave. You'll notice the geometry is a little more complicated, although I can rotate this view, and as you can see, I have a very similar wave pattern. In this lab, you're going to be examining coherent wave sources. In other words, sources that are generating waves that are the same frequency and in the same phase. In this case, phase means the drops are striking the water at the same time. The interference pattern is generated in two dimensions. You'll notice this area is a nodal line. This is where crests are meeting troughs, and we're getting essentially no waves.